Edgar Douglas Adrian is the English neurophysiologist who studied, the electrophysiology, the nature of electrical current flow along axonal wires, and won the Nobel Prize with Sir Charles Sherrington in 1932 for physiology or medicine. He really highlighted the sort of consistency of these electrical messages, regardless of which neuron they happen to be traveling through. So, he actually has a very good quote from his Nobel lecture. In all the sense organs, he wrote, which give a prolonged discharge under constant stimulation, the message in the nerve fiber is composed of a rhythmic series of impulses of varying frequency. Heartline, for instance, has shown that the discharge from one of the light-sensitive receptor organs in the eye of limulus is a fairly close copy of that from a frog's muscle spindle. With some kinds of sense organ, there is a rapid adaptation to the stimulus. This is what we're going to see later is called fast adaptation. Some stimuli, sensory neurons, they respond quickly with a volley of action potentials, and then it stops. It sort of adapts fast. While in others, there's a slower adaptation. It fires in response to a stimulus and maintains firing, throughout. Those are slowly adapting stimuli. Now, Douglas Adrian identified then the sort of consistency of the action potential of the neuronal response. I mean, there could be differences in terms of how long it would persist, but the action potential, along different neurons is pretty much the same. So, what determines, what perception you're going to get if the actual electrical message is so consistent? So it turns out that, it depends a lot on which neurons are initiating these action potentials, right? Which neurons are sending the messages. And again, we're going to see there are all of these specialized sensory afferent cells, and they have evolved specializations to detect and respond with action potentials, or respond with some kind of electrophysiological change. Specific selective forms of energy, of stimuli. And that's important. So, things that are coming in and striking your hair cells in your inner ear are going to generate perceptual experiences, ultimately of sound, of perceived sound. And those, from the body touching are going to basically generate, perceptual experiences that relate to somatosensation, mechanoreception, detection of touch and position sense and things like that. And so it's the specialized, like which cells are responding to which energies, right? Which afferents, which sensory neurons are initiating those consistent action potentials. And then also, where does that information go in the nervous system? So the wiring, the network is critical. We're going to see, for example, that, your perception of what you are seeing in terms of like what specific objects or people or, events that you are perceiving has a lot to do with, the distribution of this information, that's being detected at the retina and the eyes, the specific distribution along networks in the occipital lobe at the back of the brain and into the temporal lobes of the brain, which are going to be essential, we're going to see, for recognizing specific objects perceptually, like for, being conscious and experiencing those perceptual experiences. For audition, it's going to be in portions of the temporal lobe. For somatosensation, for the specific mechanoreceptive inputs, the position sense, what am I touching, etc. That's going to be in the parietal lobe. So the distribution of those parietal networks is going to be essential. We'll see if you damage, specific areas of the cortex that are essential for the perception of different types of, sensory stimuli. You may still have reflexive responses, to those stimuli, but you will lose your perceptual experiences of those stimuli. So, Edgar Douglas Adrian, just to sort of summarize, he described these stereotyped electrical responses of all neurons. They all had action potentials that were very, kind of stereotyped and consistent. And then so what had to be essential for, your perceptual experiences of sound versus light versus touch versus taste was the specific sensory afferents that were responding, to particular stimuli with those volleys of action potentials, and the specific network in the brain where this information was being